Hello, I'm going to, um, you know, work on the second example in the section, work it through. This example is to find the inflection points of the function f equals e to the negative x squared. We need to find the inflection points. So first, what does it mean by inflection points? There are the points where the second derivative is 0 or does not exist. That's where the concavity of the graph of the function changes. But we're going to see, we only need to find the points where the second derivative is 0. There's no value of x for which the second derivative does not exist. So let's just start from taking the derivative of the function, and we're going to use this formula in here, apply chain rule to the exponential function. So it says when you take the derivative of the e to the f of x, it's equal to e to the f of x times f prime. Okay, so that's the chain rule in exponential functions. So let's just use the chain rule in here to find the derivative of the function. Okay, so f prime, okay, of x, okay, so it's equal to e to the negative x squared. So that's the original function on the formula times the derivative of the exponent. Okay. So that's the derivative of negative x squared. So that's negative x squared prime. And we know negative x squared prime just negative 2x. The derivative of x squared is 2x. So that's e to the negative x squared times negative 2x. Okay. But we know we can put negative 2x in front. Okay. That's negative 2x times e to the negative x squared. And then we need to find the inflection points. So we need to take the second derivative. Okay. So we need to take the derivative of this negative 2x e to the x squared. In order to do that, we're going to use another rule, as you see. That's the product rule. So the second derivative of the function, all right, is equal to, okay, first, we can identify two functions in here, negative 2x and e to the negative x squared. So that's a product of two functions. And we need to take the derivative of this f prime, this function. So we have to use the product rule. So the product rule says when you take the derivative of the product of two functions, it's the derivative of the first function times the second direction, function plus the first function times the derivative of the second function. So that's what? That's negative 2x prime. So the derivative of the first function times the second function plus the second function times the derivative of the second function. Okay, so that's e to negative x squared prime. And we know negative 2x prime is negative 2 times x prime. So the derivative of x is just 1. So negative 2 times 1. So that's just negative 2. We get negative 2 times e to negative x squared in this first term. And then plus negative 2x. And the derivative of e to the negative x squared, we already did it in the first step when we try to find the derivative of f. You know, the derivative of f is just derivative of e to negative x squared. Okay, that's exactly what we have in here. And that's equal to negative 2x e to the negative x squared. Okay, so then we can simplify the answer a little bit. So keep the first term unchanged. So that's negative 2 e to the negative x squared. And then if you multiply negative 2x with negative 2x, we get a 4x squared. Right? And the other thing is just the e to the negative x squared. Okay. All right. So that's the second derivative of the function. And in order to find inflection points, we need to set that equal to 0, or we need to find what value of x that make the second derivative not existing. And we know that, you know, you can plug in any numbers of x, and the second derivative makes sense. So there's no value of x for which the second derivative does not exist. But we do find some values of x for which the second derivative is 0. So set f double prime equal to 0. Okay, so we got what? This equation equal to 0. Okay. Negative 2 e to negative x squared. Plus 4x squared e to negative x squared equal to 0. And that can be easily solved. So if we factor out e to the negative x squared on both sides, then we're going to find, you know, it just becomes a quadratic equation. Okay, so why don't we just factor out e to the negative x squared? Okay, so I guess I just copy it here. So factor out e to negative x squared from the left hand side, you know, from those terms on the left hand side. So we got negative 2 plus 4x squared left on the left hand side in the parentheses, isn't it? Okay, now we know the exponential function e to the negative x squared will never be 0. So the only thing that can be 0 is just the inside of a parenthesis. So we got negative 2 plus 4x squared equal to 0. And to solve that, we just move 2 to the right hand side. And then we're going to divide by 2. Okay. Okay, so and afterwards we're going to, take the root, but we have to divide by 2 on both sides first, or divide by 4 on both sides first. So if you divide by 4 on both sides, you get the x squared equals 204 but we can further simplify this fraction on the right hand side as 1/2 if you do cancel 2 from the top and the bottom. Okay, so now you take the root on both sides of the equation. You just get a solution. You get a solution. So x equals, now remember, we always got 2 solutions when you take the square root. Okay, so that's plus or minus square root of 1/2. And that's the answer. So there are 2 inflection points. For this function, okay?